18 of 8,500 people vaccinated against a certain disease later developed the disease. 29 of 10,000 people vaccinated with a placebo later developed the disease. Test the claim that the vaccine is effective in lowering the incidence of the disease. Use a significance level of 0.01. The first thing I want to discuss is what the word incidence means. Incidence is sort of a public health word and has made its way into this example, and I see incidence as the word occurrence. So let's reread the last sentence. Test the claim that the vaccine is effective in lowering the occurrence of the disease. So the first thing we want to do when we encounter one of these problems is think to ourselves, is this proportions or means? If we look at the information in the problem, we can see that the evidence was given to us out at like 18 of 8,500, 29 of 10,000. This type of evidence is consistent with proportions. The next question is, are there two samples or one? Well, if we look, we were given the entire information about two samples. Thus, we have two samples in this problem. The reason I'm asking these questions is because it will help me determine what my hypothesis statements will look like in this problem. So, I also want to consider the lingering question or idea they had in the problem, which was lower the incidence means that we would be able to have a smaller proportion of those in the vaccine group that contracted disease compared to the placebo group. So I have two proportions, two samples, and this idea of lowering the incidence of disease in the vaccine group. Using those three facts, I can put my hypothesis statements together. You can see I chose P for proportions. The null hypothesis will have the equals to in it, as it has with all of our other null hypotheses. And we can see the idea of lowering or less than here in the alternative. Now, if you don't mind, instead of using the generic 1 and 2s as the subscripts here, I used V for vaccine and P for placebo. It will just help us to sort of remember which each group represents. As with all of our hypothesis testings thus far, we need to consider the assumptions and conditions. So we have to consider the randomization. So the thing we'll need to assume in this problem is that the individuals were randomly selected into either the vaccine or placebo group. This is a common thing to assume in large-scale studies is this. Independence. We will need to feel comfortable assuming that the incidence of disease in one group, that is the vaccine sample, is independent of the placebo sample. I feel safe assuming that. And lastly, the success-failure condition. We need to be certain that there are at least 10 successes and 10 failures in each sample. And in fact, there are. All of this being said, it means that we can use the normal model to solve this question. So now we're going to get to the math of this, the mechanics I've called it also. And before we do, and I'm going to use Statcrunch to help us along with this, I want to organize our information. We clearly have two groups here, two samples, vaccine and placebo. And here, in this table, I wanted to clearly talk about the number of successes in the vaccine group out of the 8,500 that they had in that group. And here with the subscript little p, we have the number of successes in the placebo group and the number that they had in that group. So again, as I mentioned, we're going to use Statcrunch to solve this problem. So if you take a moment, pause the video, and possibly you can open up Statcrunch and work along with me in learning how to do this. So in Statcrunch, you want to go to your spreadsheet where you have all your buttons available to you. To do a two-sample proportions hypothesis test, you are going to want to hit Stat, next Proportion Stats. This time we'll choose two sample and with summary. this pop-up box will appear, and it's going to need several bits of information from you. Sample 1, the number of successes, the number of observations. Sample 2, the number of successes, the number of observations. How you determine which group is sample 1 and sample 2 is from remembering sample 1 is the group that's on the left side of your hypothesis statements. For us, I listed the vaccine group first. Sample 2 are those that are on the right side of your hypothesis statements. For ours, I put the placebo group. So when I come in here and put the information in, 18 people developed the disease out of the 8,500 in the vaccine group, that's my sample 1. Sample 2, 29 of those in the placebo group that had 10,000 people developed the disease. So I've told Statcrunch our evidence. The next thing I need to tell it is what our hypothesis statements look like. Statcrunch takes a slightly different approach in writing their hypothesis statements, but it is in fact the same thing. We will use the less than here, because in ours we have less than. Double check your entries that you chose the right alternative, ours was less than, and hit compute. And you can see our solution. The thing we're most interested in, although it's nice to check and double check that all of your stuff you put into Statcrunch is correct and there were no typos, but we're going to focus here on the last two columns. The z-stat, or z-score you can think of it, was negative 1.05. The p-value was 0.1461. So a smaller z-score coupled with a larger probability. We're going to use these two pieces of information to make a decision. I took the information from Statcrunch, the z-statistic, and the probability value, and typed them in here so we could reference them. We want to use these two pieces of information to make a decision in our hypothesis test. So we typically have been making our decision with the probability value. Again, the probability value comes from, if you were doing this by hand, looking up the z-score in our normal table. Statcrunch does it for us automatically. Our decision. Let's put this probability value next to our significance level we were given. Our significance level was 0.01, and our probability value, or p-value for short, is 0.1461. We can clearly see that the p-value is much larger than alpha, our significance level. That's going to lead us to make what decision? If you said retain the null hypothesis, you would be right. So in a sense, here are two hypothesis statements that we had from the beginning of the problem. The null being that the vaccine group was the same as the placebo group, and the alternative saying the vaccine group had a lower incidence than the placebo group. We're going to have to keep our null hypothesis. Thus, this is what we leave the testing process with. Our assumed truth of the null hypothesis still remains. Let's make a sentence. The sample data suggests that the vaccine group is not effective in lowering the incidence of disease. The reason I'm saying this is because our takeaway from the process was that the vaccine group was essentially the same as the placebo group. So unfortunately, maybe the makers of this vaccine, the people promoting it, probably won't be happy with this information because the hypothesis test said that there's no advantage in the vaccine over the placebo.